Let's go.
Engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon.
Integrity AMG high.
The most powerful.
We currently live in an age where machines define the frontier of space. Robotic orbiters map the lunar surface in ultra-high definition, while the James Webb Space Telescope peers into the infrared signatures of the early universe. But robots have limits. To push past them, NASA built the Space Launch System, a heavy-lift rocket returning a human presence to deep space for the first time in over 50 years. The Artemis II crew consists of Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen. This team includes the first woman, the first person of color, and the first non-American to ever leave Earth's orbit for the moon. Their 10-day mission aboard the Orion capsule takes them on a high-speed loop around the lunar far side, though they will not be attempting a landing on this specific flight. From an engineering standpoint, the crew functions as a biological load. NASA must prove that Orion's life support systems can successfully scrub carbon dioxide and regulate temperature, while 4 humans are breathing and sweating inside the cabin for over a week. However, sensors and telemetry can only validate the hardware. For the actual science of the flyby, NASA relies on the human eye, a biological sensor with a receptor density far outweighing any digital camera, to interpret the lunar environment in real time. On day 6, the mission reaches its climax. The Orion capsule drops to within 4,067 miles of the lunar surface. As the spacecraft slips behind the moon, the lunar mass severs all radio contact with Houston. For 40 minutes, as the Earth vanishes from view, the crew enters a total communication blackout. Operating in the silence of the far side, the astronauts began a direct visual survey of the Orion-Talley Basin. For identifying subtle variations in shades of brown and blue, they were able to distinguish between different mineral types and estimate the ages of geological features with the naked eye. During this window, the crew reported seeing 4 distinct impact flashes, the quick, bright bursts of light caused by meteors striking the lunar surface in real time. This is the specific advantage of a human crew. While a robotic camera records a set field of view, the human brain can instantly detect, filter, and contextualize these unexpected anomalies as they happen. As they emerged from the blackout, the crew officially reached a distance of 252,756 miles from Earth, breaking the all-time record for the furthest humans have ever traveled from their home planet. This is a diagram of the free return trajectory. By following this figure-8 path, the spacecraft uses lunar gravity to naturally slingshot back toward Earth, requiring almost no engine propulsion. NASA relied on this exact maneuver in 1970 during Apollo 13. When an oxygen tank explosion forced the crew to cancel their landing, the free return trajectory became their only viable path for survival. The Artemis crew acknowledged this history by carrying a silk flight patch from the Apollo 8 mission and playing a pre-recorded message from the late Jim Lovell, the commander who led Apollo 13 through that 1970 crisis. Following the flyby, the crew requested to name a newly documented crater Carroll, a tribute to Commander Reed Wiseman's wife, who passed away in 2020. Artemis II took a flight plan originally designed as an emergency escape and turned it into a deliberate test of the limits of modern deep space exploration. Before leaving the moon's influence, the crew donned protective eclipse glasses to witness a total solar eclipse from a vantage point 250,000 miles away. Without an atmosphere to scatter the light, the sun appeared as a sharp white disk that was instantly replaced by a glowing, ethereal corona the moment the moon's edge blocked the solar surface. The result was a surreal optical illusion, a black lunar orb framed by a solar halo, while the side of the moon facing the astronauts was simultaneously lit by Earthshine, sunlight reflecting off our home planet. This is an alien sensory experience that no camera can fully translate, an environment the human brain has not evolved to process. After 9 days in space, Orion reoriented itself for a high-speed re-entry into Earth's atmosphere and a final splashdown in the Pacific Ocean near San Diego. The mission's technical success was defined by the flawless operation of the spacecraft's core hardware. Every valve and circuit in the Orion capsule underwent a total system stress test during the transit. The flight successfully validated the life support, propulsion, and navigation systems required for sustained operations in the deep space environment. Looking past the receding moon, Commander Wiseman noted the crew's focus had already shifted to a bright red dot shining in the void: Mars. Artemis II was the necessary shakedown cruise for the next century of exploration. By proving these systems with humans on board, NASA has established the technological and psychological groundwork for humanity to become a two-planet species.
So proud to be a part of this program.
Well, I have to say I spoke to a very